So it's my great pleasure to introduce our next speaker, Dr. Carolyn Chung. She is the Chief Data Officer and the Director of the Data Ecosystem Institute of Data Science for Oncology at the University of Texas, MD Anderson Cancer Center. Dr. Chung and Dr. Wilcox actually just recently, in conjunction with another committee of national academies, they published a really important and timely report on digital twin. It's called On Foundational Research Gaps and Future Directions for Digital Twins. I highly recommend that you might take a look at it. I love the definition that they have put here. The rest of your bio is on the website. Welcome, thank you.
Thank you so much, Rizbe. It's been a pleasure being here. Thank you for the invitation, and it's been a stimulating day and a half of presentations, discussions, and so I thought I would close off the medicine session with a bit of provocative thought, some reflections that really reflect many of the observations that I've been seeing, as well as hearing from my patients, various clinicians, researchers, and really starting to ground ourselves in the fact that medicine is a science of uncertainty and art of probability. And I didn't make this up. This actually came from our forefathers. And so if we look back and ground ourselves to the roots of medicine, we look at Hippocrates, and he starts with the statement that science is the father of knowledge. And I think everyone in this room would attest to the fact that that statement is true. But opinion breeds ignorance. And we heard from the colonel around egos of pilots, and I would say that the equivalent to the egos of pilots that may prohibit us to actually move things forward are the dogmas that often sit within medicine. And so how do we actually overcome the dogmas that exist and start to really look at the science and the data? And I think that the AI era has started to bring forward the data and the focus on the data and the actual observations that we're dealing with. Our modern father of medicine, William Osler, who I'd probably say is Canadian, I'm Canadian, is medicine is a science of uncertainty and an art of probability. And what a statement that is in an era of AI. And I think that is something that we should really resonate on and think about what is the uncertainty in the models that are being presented, knowing that they are often probabilities that are being presented. And finally, they've both used this quote, is that it's more important to know what person has a disease than to know what disease that person has. And so really taking the patient holistically, understanding that it's not more, that there's much more than just the disease that you're dealing with in that moment, but the entire person. And I think that really starts to bring forward the equity issues that many people think about, the circumstances people may be in that result in the choices that they make, the treatments that they undergo, and the outcomes that they may experience. And so how do we actually start to embed all of this thinking into the technology that we have potentially at our fingertips? So given that that was our roots in terms of where medicine has started, why have we struggled to adopt data-driven tools in medicine? When I say adopt, I don't mean discovering a new paper, publishing. There's many exciting publications, many that you've seen highlighted even today. But how many of these are truly actually getting into the clinic and really affecting how we actually deliver care? If you look here, this is the practice of medicine. I made an analogy to weather and where we are in weather today. And the practice of medicine with literally bedside care, I would liken to the weather vane. You sit in front of the patient, you talk to the patient, you examine the patient, and you kind of get a sense of what that patient is doing in that moment, a snapshot. Where is the wind blowing? We start to talk about evidence-based medicine, when we actually start doing systematic reviews. I liken that to the Farmer's Almanac. Someone made a reference to the Farmer's Almanac earlier in the meeting. And it does actually do a good job at predicting really big patterns. And the systematic reviews do the same. We can actually look at the published literature and we can get recommendations at very big strokes. But when you have a patient sitting in front of you, I'm a practicing clinician, and you're trying to make a decision on that individual patient, this is helpful to know, and you may know where that patient falls into the bigger category of the population of patients, but you kind of want to know what is happening with the patient much more in that time scale of a weather map of the hurricane coming in or a storm coming in and knowing how you should actually react. As a cancer physician, that literally is what we're trying to deal with, a giant hurricane that is life-changing and all the data coming in. We have multiple data streams. We heard about a lot of them today. But how do you actually integrate that into that decision-making? And how do we actually start tackling the really impactful questions to allow for that data-driven clinical optimization? And tackling the impactful questions and actually defining those impactful questions is a much harder task than we actually think it is. And we often focus on the availability of data, but how much of that data is truly usable when it actually comes to tools and models that we're going to use for implementation? And what does it actually take for effective implementation to the impact of the patient? And one of the challenges that we have is this impactful question can be hindered by the fact that data scientists may stand on one side of this bridge and the clinicians that are trying to develop the questions are standing on the other side of this bridge. And Eric Topol there's a quote from Digital Medicine by Eric Topol and Dr. Keane, is that there's a lack of awareness of the so-called AI chasm. And I think this room is aware. We're talking about educating and bringing people together and having this cross-dialogue, because developing a scientifically sound algorithm is fine, but to actually implement it in real-world settings is a much bigger leap. And I would say that context is that critical bridge to realize the impact. And I'll walk you through some of the contextual challenges in clinical medicine today, some of the contextual, honest realities of how data is generated and flowed today that is actually going to hopefully give you some insight into the types of tools that we actually need to develop out and to create a bridge across this chasm. So we just launched the Institute for Data Science and Oncology at MD Anderson. And we really started to think about what was the mission of this institute as opposed to any other data science institute in the world. And the thing that we felt that we really wanted to do was unlock that power of the data, but it had to drive all the way through to impactful change for the patient. That's where our unique position is, that we see a large number of patients. We want to network out with other institutions that see even larger numbers of patients, but to develop out tools that can answer some pragmatic questions around intelligent systems around quality and safety of care delivery, streamlining access. We were just talking about equity of access to care, as well as the piece that everyone wants to focus on is predicting the future and predicting outcomes for our patients to really personalize care. Yes, we want to do that, but we have to do that with these other pieces in mind. And there was an equation that we kind of came up with that needed to come together for us to actually realize this. One was to bring the talent together. And this talent is not just medical research talent. This is not just data science talent. We wanted to learn from data scientists who are not only looking at the medical field. We wanted to learn for data scientists who are exploring engineering problems, who are exploring climate problems. And so the spirit of TAMEST is very much resonating with what our goals were, because there are methods that we can actually learn from across disciplines and apply to medicine. And we need to have that conversation, and we need to bring together the culture of enabling that true team data science. But that means understanding the limitations of how that data is generated, and I'll give you some insights around that, as well as the limitations of how these tools could potentially actually be implemented. And this is building out that ecosystem that we are aspiring to build out over time. And so what does it take to build out this ecosystem? We started with the cultural engagement, and one piece is growing data literacy. So we've actually started a data literacy course at MD Anderson. Texas DIR has also mandated a data literacy course across the state, for those of you who are not aware. And so there is an effort across the state to actually bring data literacy forward. In my definition of data literacy, I consider that not just literacy around the data, but how to actually use the data, and that encompasses AI. And so how do we actually bring people to a better understanding of what are these tools actually doing? What do the outputs actually mean? How do I make sound decisions with the outputs? Secondly, we started to align our core value at our institution of stewardship. Many people think of stewardship as financial stewardship. I would say that I like that analogy because if you think of giving your money to your financial advisor, that person locked it up safely and just made sure that no one stole your money, and you came back 5 years later and he's like, well, your money's safe and you've made not 1 cent, but your money is safe. I don't think any of us would be particularly happy. The goal of stewardship is to actually also make sure that you're investing and bringing value with that investment. And so when we think about data stewardship, we want to protect our data. We certainly don't want any nefarious acts to happen, but we also want to bring value from our data. And so we started to embrace that idea of holistic stewardship to our data. And this includes improving the quality of data at the point of generation, at that first mile. When you think about many of the data science approaches up until this point, it's that, again, imagine that bridge and there's a gaping hole and people are throwing data over the fence to the data scientists saying, please do something useful with this. When you take that approach, then you're cleaning the data at the nth mile, just before you're going to use the data. If we know that our data is growing at an exponential rate, your magnitude of work that you need to do to actually improve data when you're generating it relative to when you want to use it is an exponential difference. And so this is where we want to start to take that first mile strategy around data quality. The second piece was building the shared contextual understanding around our data. We each come to this data, you see rows and columns, but you may not fully understand and appreciate how did that data come to be. And this may actually result in you using the data inappropriately, not badly, but coming to conclusions and finding patterns that are not truly in the data because you've made assumptions of what is or is not the same. And so we started to bring forward this concept of creating this transparency, having quality of the data actually explicitly measured out, the uncertainties in that data itself explicitly measured out, so that people can actually see what is in that data, what is not in that data, what are assumptions that were made, and can we actually combine these? Are these apples and oranges? Or are these apples and bridges? So are they even in the same genome, right? So that's one piece, and then building out this operational framework so that we can actually bring this forward with that transparency. And so the reason for all of this is because the reality of data generation and flow in healthcare is that it's labor intensive and it's messy. And it's because we've started in a practice era where we see patients, we see one, do one, teach one. Those of you who are physicians would know that phrase. And we often did the clinical assessments in a qualitative manner. When we actually switched and moved into the electronic health record, and you can imagine the next time, for those of you who are clinicians, if you're clicking through the electronic health record, it looks a lot like a binder. And it's because they've recreated the binder that we used to see. And some of you may have had relatives in the binder era where there were stacks of binders if they had a lot of health issues. And there were sections that you would have to sift through to actually find the labs and the clinical notes and other pieces. And they've recreated that as opposed to really thinking about, now that we're in the digital era, how should we actually be generating this data? And that has really prohibited us from actually standardizing and structuring our data and moving this forward in a way that we can actually truly leverage the technology. And I think that right now we're kind of in this era of standardized and structured reporting, and we're suddenly doing it at massive volumes because we've already converted to the electronic health record. And so how do we actually keep the physicians from feeling like assembly workers? We're going to have to somehow figure out, and this is an area where I think that AI could actually be leveraged more effectively for us to start to really bring forward the automation and the computer-assisted medical care. So in order for us to do this, this is the massive transformation, but if we're not intentional, we're going to constantly be fighting against this messiness in the medical chart. So this is my definition. I've come up with an acronym to help you. But in my definition of culture, and when we say we want to change culture, I consider it the common understanding of language, and I want to emphasize the language, and thoughts and motivations. We need to have the shared motivations to unfetter relationships across the ecosystem and the holistic ecosystem. And the reason why this definition came to me is that culture is learned. It can evolve. It is a common understanding, but it also is really grounded in the words that we use and how we actually receive the words. And so given that my talk was after lunch, I thought I would start with this exercise of this one word, the word interesting. And please participate. Please raise your hands if you've actually used this adjective, meaning something that is positive. Okay, great. Now be honest. Please raise your hands if you've actually used this adjective to mean something that's not so positive. Right, so thank you for your honesty. I think this will tell you that, these words, these qualitative descriptions can mean many different things. And when you actually think about it, standardization of terminology, when we think about standardization and interoperability, there's a lot of discussion around machine readability and interoperability. Everyone's really focusing on the syntax, right? Can this thing flow in here and things don't break? That syntactic interoperability does not help you know if someone said, oh, that's really interesting, or yeah, that's really interesting, right? So there's that intonation and that context. And so this context informs the semantics. And so how do we start to capture the context in the data that we actually generate? And so there's a paper that I've published at the end of December in Cancer Research. It was actually entitled, Cancer Needs a Metadata Supply Chain to Realize the Promise of AI in Cancer Medicine. And it really starts with observations in context. And the context can be captured in the metadata. So if you start to think about blood pressure, very simple, machine readable number, it's a single number, or even more simple, a heart rate. So everyone knows that heart rate, if I say 60, most people know the standardized unit is beats per minute. And so let's say you have a heart rate of 120. The context of it would really matter. So if you're on a treadmill and you're at the cardiologist assessment, you're running at 120 but been running for the last 5 minutes, they say you're really fit. your heart rate's pretty good. But if you've been lying in bed and you're in an ICU bed and you've got a fever and you've got a heart rate of 120, they better have the cardiac monitor on you because there's something going on with your heart. And if you're at home, you probably should be calling 911. So how do you capture that context? Well, the machine that has read the device, potentially the other vitals that are being measured around you. If you're using it on your Apple Watch, it may actually tell you how many steps you're taking or what activity that you're doing or the movement. All of these contextual pieces are not necessarily additional work. They're just not necessarily flowed in to your rows and columns as you're considering the data. And so imagine when you get big population sets of data and you're getting that row or that column of heart rate or blood pressure, and you don't have that context. You just start compiling all of the patients without realizing what was that measurement, how was that measurement taken, what was the circumstances, and imagine the types of patterns you may see in your analyses if you don't actually consider that context. The second piece was the dynamic assessment of quality based on the context. So the context itself can affect the quality. So if I'm using my Apple Watch or being on a telemetry machine, the precision of a telemetry machine is substantially better. An Apple Watch is not a medical device. That's what their qualifier is. It's not medical. So the error rate is much bigger. So that can reflect quality. But it also should be that the context of use of that data may allow you to have data that's less precise. If you're not making a decision of a single patient sitting in the ICU, you're just looking at general patterns or you're exploring. Perhaps you don't care if people are using the Apple Watch because you're just looking for big patterns. So that context of use can also demand a certain quality of data. And so you need to make sure that you're considering what is the uncertainty around the measurement relative to the kind of question that you're trying to ask. The third piece is that the provenance, so where has that data come from, and what is that flow of that data, and has anything changed along the way, should actually affect the confidence that you have in the insights that you make. So if you've gotten data sets from all over, perhaps you're trying to build an AI model and you've gotten it from large anonymized public data sets where you don't have all of these quality measures, you don't have all the context, then you need to make sure that you're accounting for the fact that there are a lot of unknowns in your data set. And so your output ultimately is going to be somewhat exploratory. You're going to have to go and verify further with additional data. And finally, unless you can integrate this through, so this is the piece that we have to be intentional with doing this, because it just doesn't happen magically. We have to be intentional and coordinate this together. And there are lots of examples of context being ignored and outcomes not being so great. So these are public record. This was published in 2021 looking at AI models. In the AI model, it was an epic failure in EPIC around sepsis. Similarly, there was an MIT report that looked at all the COVID, we just talked about COVID, the COVID AI models trying to look at chest X-ray imaging and distinguishing whether it could diagnose COVID versus not COVID. Sounds like a very useful tool. Having said that, what happened with the MIT report is when they looked closer, they realized why these models were not doing well. So hundreds of AI experts around the world banded together to develop these models. Many, many models were generated. And they all looked promising when you actually looked at the baseline statistics of performance that we often look at in an AI model. Then they deployed it out into the emergency rooms, and they started to royally fail, much like the EPIC one. Now, why did that happen? It was because the patients who were very early in the pandemic, the patients who didn't have COVID were largely pediatric. And so these models were learning pediatric versus adult lungs as opposed to truly COVID versus no COVID. When you put it into an emergency room and try to diagnose COVID in an adult, well, you're getting a bunch of false positives because the data, and so you ignored the metadata, that contextual information, the age of the patient, as you were actually starting to build the models. So for those of you who are working on models, please consider this as you start to think through. Similarly, the resounding enthusiasm to actually use real-world data in the EHR, I want to give you some sobering realities of what is in the EHR. This was a recent publication from JAMA that showed the sources of duplicate information in an electronic medical record. These can be duplicates of errors in the medical record. Not to say that I don't want to get everyone walking out of here completely depressed that we don't know how to treat people. We give good treatment. The documentation is just not necessarily as precise as we'd like it to be. And so what happens is that perhaps the decision is made right, but the relevant information that led to the correct treatment and a good outcome for the patient was not in the medical record. They would happen over phone calls because the physician's clicking around going, this doesn't make sense. I'm going to call my colleague who actually referred the patient. We're going to have a conversation, and then we realize what the actual story is. Didn't necessarily correct it all, or perhaps that one document had the correct story, but all of the other copies, copy and paste, were errors prior to. And so how do you actually, if you were to deploy an LLM into that setting, it's going to comb through and it'll see the most copies of the erroneous message, and that may become truth. There was a recent quote in the LLM Gen AI hype, the stories that came out, and one was that if you say something enough times, it becomes truth. And this is the potential risk of using the EHR. So it's not to say that I'm discouraging research using EHR, it's being aware of the potential vulnerabilities of doing this. And what do we need to do to move forward and make sure that the data in the EHR is more meaningful? Because ultimately, if you're taking data, cleaning it, and then training a model, and then you're deploying it out into the wild, and this is the data that is going to be used to actually run the model, you can imagine where the disconnect is. So another example is around imaging. So this is the quantitative imaging workflow for those of you who are not aware. If we want to actually measure something quantitative out of images, you acquire the image, and if you vary the way that you acquire the image, you're going to vary the precision in your measurement. You post-process the image. If you vary the way that you post-process the image, you're also going to vary the measurement. You may register multiple image sets across time. And if that registration method is different, you're going to vary the measurement of the image. You may segment, and you may extract some feature that you find as useful that will predict out to, a particular molecular profile or genetic mutation or a particular clinical outcome. But variations along this path will result in variations in your assumptions that you're actually making. And so variability at any one of these steps can actually hinder AI development. And here are some concrete examples. So this is a project that I did with a postdoc in my lab. We were just looking at slice thicknesses of brain MRIs. And patients who develop brain metastases, these are secondary tumors that grow in the brain from other solid malignancies like breast cancer or lung cancer. And many of these patients, when they're detected on MRI, their tumors are only 1 or 2 millimeters. And so when you actually look at this, if the patient had a 2 millimeter or 3 millimeter slice MRI, there may be differences in the size that you're actually measuring or even the detectability of those tumors. And so if you imagine a patient going from one hospital to another and they have different protocols, you may actually have patients who are considered progressing because the second hospital that they went to had a more sensitive MRI than that last hospital. And if they're considered progressing, they may actually get put on a trial, and they may not have needed to go on that trial or not necessarily even progressing and should be getting this trial treatment. So that's the kind of impact that is potential because of our variability. And so how do we start to acknowledge that these things are going to impact the measurements that we're worried about? The other piece is ground truth. So the ground truth on ground truth is that humans and observers have very variable measurements. And so this was a study that I did with a postdoc student or a PhD student of mine. This was gamma knife treatment cases. And so patients were, experts were receiving these images at 16 different gamma knife centers, the most precise way to deliver radiation. And you can see that the pink is the all-encompassing volume that people had delineated. The large purple was the 50% agreement. The small purple was the 100% agreement. This is not small differences. These are big differences. And so just remember that your ground truth data may or may not have variations, and even your user acceptance testing may or may not have variations in terms of what humans are telling you. The other piece around it is the image resolution. These pixelated images are real images drawn out from the community. So this is the heterogeneity that we're actually seeing, and you can see how it actually affects the performance of diagnosing these particular diagnoses that this AI model had been training to categorize. Finally, the final piece is that the context of implementation can be quite different. So if you're training on this kind of data set and you're implementing in a patient with a lung that looks like this, you cannot expect that tumor or that model to actually perform equivalently. And so I think these are the kinds of scenarios that I think we need to really start to think about in terms of implementation. So I will skip through this, and I will just talk through actually, let me just go back to this piece. So I think as we start to think through the model lifecycle, many people start with what data is available. I think we really need to pause at what is the problem or question we're trying to answer, and that should be tied to the subject matter expert talking with those who are doing the model training and validation. The operational and stakeholder readiness to actually receive these models and thinking about model implementation. Understanding all of the model outputs by the stakeholders and considering the model outputs with uncertainty and communication. And everyone kind of thinks about model ops as the main piece, but this whole cycle needs to have these bridges across to actually make sure that we're actually building models that can be implemented to impact. So I will skip through this for the sake of time. There's a great paper that we had written with partnership with Tom Yankeloff and team around designing clinical trials for patients who are not average, alluding to the digital twin. And for those of you who are interested, there's a paper on practical approaches to the digital twin that really talk about starting with what is the goal of the digital twin. So again, starting with the question, grounding ourselves in that question, and thinking through, if you are interested, please refer to, you can scan this QR code for the foundational research gaps and future directions for the digital twins. Thank you.
Thank you so much, Dr. Chung. I think we don't have time for, unfortunately, Q&A, if that's okay. So we will just proceed, but then we'll have time outside. Thank you so much, Dr. Chung.